Okay, moving on to example 2. This has square roots again instead of cube roots, but it's got 2 of them. We got a square root of k minus 5 minus the square root of k plus 1 is supposed to equal 0. And our first task is always to isolate the radical, but now we've got 2 radicals, so I can't really isolate the radical. What I can do is isolate one of the radicals. And here's my deciding factor on which one I isolate. Which one's uglier? The one with more stuff in it, okay? So the one with more stuff in it is the one I'm going to isolate first. So I'm going to get that one by itself. I'm going to move everything else to the other side. So if I do that, I'm going to get the square root of k minus 5 staying on the left-hand side equals the square root of k and the 1 are both moving. The square root of k is negative, moves over, becomes positive square root of k. The positive one moves over, becomes minus 1. And notice that minus 1 is outside the radical, so make sure you write it that way. The reason I want the more complicated radical isolated by itself is, again, my next task is to get rid of the radical, the one I've isolated. This is a square root, which is an index of 2, so squaring gets rid of it, right? I'm going to square this side also, because whatever you do to one side, you do to the other side. By isolating the more complicated looking radical, I've taken the easy step here on the more complicated radical. Squaring a square root just gets rid of the radical, leaving us with whatever's underneath. So again, I've made the more complicated one easy. I make the less complicated one the more difficult side. What I have is a binomial squared. And again, it's the square root of k minus 1 being multiplied by the square root of k minus 1. That's what's happening here. It's not just going to be k plus 1. Alright? So keep that in mind. Square root of k times the square root of k makes k. Negative 1 times negative 1 makes plus 1, the two things that everybody would expect to be there. But there's also the outside product of negative the square root of k, the inside product of negative the square root of k, making a total of negative 2 square roots of k. And then we got the plus 1 in the k. Now, that's the FOIL technique. That gets you the correct result, right? We can put back over here. So again, if I'm going to FOIL, scratch it to paper, FOIL it, transfer back over. I prefer, hopefully, that you guys become comfortable with this whole squaring a binomial idea. Squaring a binomial is a three things. We create a trinomial, right? You square the first object. Square root of k times itself is k. You double the product. Negative square root of k doubled is negative 2 square root of k. You square the second object, plus 1. Squares are always positive. Same result. Can be done mentally. Works every time. Become comfortable with that because it happens a lot. This squaring a binomial thing happens hundreds of times this year, another couple hundred times next year, probably about 500 times in calculus. It just happens again and again and again. So if you have this little shortcut that every time you see this structure, square, double product, square, it just makes life easier. Speeds you up. All right? So it's worth figuring it out. Now, once I've gotten rid of this, so notice I had 2 radicals. I squared both sides after isolating one of the radicals. Now I'm down to a single radical. Okay, that's what happens. If you have 2 radicals and you square both sides, you should be down to 1 radical. Then you're going to be back to the 1 radical technique, which is isolate the 1 radical. I'm going to take the negative 2 square root of k to the left and move this stuff over to the right. It's not a requirement to move to the left. I just like my square root term to be positive. The minus in front just makes me feel icky inside, so I don't want to do that. So I'm going to move that negative 2 square root of k over. So 2 times the square root of k moves to the right. Oops. 2 times the square root of k. It becomes positive. Notice the minus 5 moves over, becomes a plus 5, right, which is 6. And the k moves over as a minus k, and k minus k happens to cancel. So we get 2 times the square root of k is equal to 6. I'm again at a point now where the radical term is isolated. I could square both sides right now if I felt like it. All right? And if I did, this would become 4, this would become k, this would become 36. That's legal. All right? Easier. Divide both sides by whatever's in front of the square root object first. So then I'm going to square and I'm going to square. Again, you see square root equals number. Make sure you put in the step where you write the squares in there. All right? I've seen too many people just say k equals the square root of 3 there. They just take the square root sign and then they make up their rule. Well, the square root sign's over here, we just put it over there. And that's illegal, so don't do that. Square root of k equals number, you square square. So this becomes k, 3 to the second power becomes 9, which is the right answer. Whether or not it works, I don't know, but that's the right answer to the problem. As before, since we're doing a radical equation, we do have to verify solution. So I take my answer and I just put it back in the original problem. Square root minus square root plus 1 equals 0. K is equal to 9. 9 minus 5 equals 4. K is 9. Square root of 4 is 2. Square root of 9 is 3. 2 plus 1 is 3 minus 3 equals 0 is a true statement. True statement means our answer is good. Okay. Verify every time on the radical equations. When they work, fine. When they don't work, you have to empty set it.